So the question states that a copper, so this is a copper and 75. The mass of copper is 75 kilogram. That block initially at 110 degrees Celsius. So initial temperature is about 100 degrees Celsius, is dropped into an insulated tank. So this tank is insulated Q, in and out it equals to 0, and it contains the water. So the water has volume. So if I say the volume is 160 liters, so and this water is initial temperature is 15 degrees Celsius, and you have to find out the equilibrium temperature T2. So what is that temperature plus the total entropy change? So how would you find out the total entropy change? That is equal to entropy change due to the copper and entropy change due to water. So we know the formula we already studied in the previous slides, that for liquid and solids, this like C average ln T 2 over T1. I'm gonna use the same formula for that purpose, so let's use the same formula. Entropy change for liquid or solid, liquids or solids. So the entropy change is MC average ln T2 over T1. So if we know this final temperature, so we can find out the entropy change for copper as well as for water. So how can we find out the final temperature? So using the energy balance, the first law. So first law of thermodynamics, that energy going in minus energy coming out equals to change in energy of the, I'm sorry, this is not else, this is E. And there is no energy going in, no work output, so this is 0, this is 0, no energy coming out. So this one equals to delta U, because the energy of the water and the copper remains, it changes internal energy. So we know that the change in internal energy of copper and or any substance can be written as mc delta T, mc delta T. So for copper, and similarly, so we can find out for internal energy for mc water for this one. So for copper, we know that it is 75, and for the specific heat, so you can find it out from the table. So the table states the specific heat, for copper it is 0.386. So let me specific heat for copper, it is 0.386 kilojoules per kilogram Celsius from table A3. So you can take a look over there and find out. So once we know that this is the copper specific, so I can plug it in over here. So 75 times 0.386 times T2, make sure this is in Kelvin scales. So T1 is 110, so I can add this 273, so that will give me, you can leave it as in Celsius, it doesn't matter in our case, but since it's a temperature difference, so you can leave it like this. So 110 Celsius, and this is energy balance. This, make sure this is equal to 0. So you have to say like delta U for water, it is M for water, and C for water. C for water is 4.18. T2 we do not know, but T1 it is initial. So what is M for water? If we know the volume, that means the density equals to mass per unit volume. So let me write it down. The mass of water density times volume of water tank, and density, it is equal to in this case this is 997 at 25 Celsius. So you will multiply by the volume, which is 160 liters, but you will convert it into meter cubed here. So if you solve for this, you should get 159.5 kilogram of water. So now we are in good shape. You can write it down here like delta U for copper plus delta U for water, that is equal to 0, and that is equal to 75.386 T2 minus 110 plus 159.5 times 4.18 times T2 minus 15, and that is equal to 0. And if you solve for this one equation, one unknown, if you solve for this, you will get 19 Celsius, or that is also equal to 292 Kelvin. So once we found the temperature, final temperature, we can find out the entropy change using this formula. So let me use this formula for the entropy change, and so this formula we can use for both for copper as well as for water. So mass for copper is 75, C average is 0.38 386, Ln 292 over T1, this is T1, make sure this is T1, that is equal to 383. Here you will use in Kelvin scale. So if you solve for this, you will get negative 7 point, this is 0.85 kilojoules per Kelvin. And similarly you will find out the entropy change for water, and if you do the math for that one, I can use it for the entropy change for water. It is equal to mass, which is 159.5, specific heat is 4.18, Ln 292 over initial temperature is 288. So if you solve for this water is gaining energy, so it is positive, entropy change is positive. So this is your answer.